Okay, so I've started with the lecture. Okay, in the last lecture, when we stopped, we were discussing the concept of elasticities. Okay, and we have seen that there are three main types of elasticities that can be measured. Okay, one is price elasticity of demand. Okay, then we have seen income elasticity of demand. Okay, Sandhya, thanks for telling me. Is it better now? Can you hear me? Can you confirm that you are able to hear me? Hello? Am I audible now, Sandhya? Hello? Am I audible now? Hello? Sandhya, can you confirm that you are able to hear me? हां, परत तोच प्रॉब्लेम आहे का? स्पीकरला काहीतरी करावं लागेल काय? असं येतोय की रोज? Hello. Can you all hear me? Hello. Online students, can you confirm that you are able to hear me? कशामुळे होत आहे काय माहिती? Okay. Just wait a minute. Yeah. Can you confirm that you can hear? Yes, thanks. Okay, let's continue with the lecture. Okay, we have seen in yesterday's lecture three types of price elasticities. One is price elasticity, then we have seen income elasticity, and the last one we were studied was cross price elasticity. Excellent. Okay, that is cross price elasticity. Okay, now just tell me one thing. I'm writing like this. Suppose for a good X, price elasticity calculated is say 2. How will you describe the price elasticity? Will you say it is relatively inelastic, unit elastic, or is it relatively elastic? What would be your answer? Which of these three would you choose? If the price elasticity is given equal to 2, what would be your answer? If the price elasticity of a product is 2, then which A, B or C would be your answer? Is the demand relatively inelastic, it is unit elastic, or it is relatively elastic? Okay, relatively elastic is the right answer. Why? More than one, correct. So remember this, if the price elasticity is less than 1, we say it is demand is inelastic. If it is greater than 1, we say it is relatively elastic. And if it is equal to 1, we call it unit elastic. Is that fine, all of you? Even the online students, are you okay with this? Okay, good. Tell me, if income elasticity for a product calculated was negative, okay, would you call the product a superior good, neutral good, yeah, you'll call it inferior good. Again, we described these elasticities in the last lecture. Which would you choose? If when the income elasticity of a demand is negative, is the good a superior good, a neutral good, or a inferior good? A, B, or C, what would you choose? Yes? Okay, one rule that all of you should follow is that whatever we study, you have to go home and revise. Okay, because in exam time, you can never predict what kind of a question will be asked. Yeah, anybody can guess? Inferior good, that's right. It is the definition of an inferior good. Income increases, demand falls. So it will definitely be negative. Okay, and if cross elasticity calculated is negative for two goods, okay, it is negative, would you call these goods neutral, complements, or would you call that they are substitutes? If the computed cross elasticity of demand is negative, perfect, that's absolutely right. Did you get this? You have to know this, huh? I mean, there's no other option but to exactly know this. Okay, before I proceed, one another way in which you can recall these price elasticity of demand is by the following diagram. Okay, if you draw price and quantity, okay, now let me draw a diagram like this. Okay, D, let me call this as D0. Okay, what it means that even if I'm changing the price, quantity demanded is not changing, it is remaining fixed at this number. Okay, what would be the price elasticity of this demand curve? What would be the price elasticity of this demand curve? Perfectly inelastic, yes, correct, that's right. It is a price elasticity is 0, and this is a perfectly inelastic demand. Have you got this in your mind? So whenever you think about a inelastic demand, you have to think about it like a vertical line. The demand curve will be a vertical line. Okay, opposite of this, okay, opposite of this, think of a demand curve which is like this. Okay, what does this mean? At the, yes, at this going rate, you can, there is a lot of demand, but if you increase the price, the demand will fall to 0. Okay, or if you cut price, the demand will grow very large. Okay, so this demand is called perfectly elastic demand curve. This is called perfectly elastic demand curve. Have you got the graphs? Perfectly elastic demand curve has a horizontal demand and perfectly inelastic demand has a vertical demand curve. Okay, now it's not easy to plot either relatively elastic or relatively inelastic, but keep this simple rule in mind. If you see a diagram where the demand curve is more like a vertical line, then we can say the demand is relatively inelastic. And if the demand curve is more like a horizontal, flat, then it would be elastic. Okay, so you get something like this. This demand curve will be relatively inelastic. Okay, and if you get a diagram like this, let me draw with a different color. One of the advantages of doing this kind of a lecture is that you can change the ink at your will. Okay, it would be a flat line like this. This demand curve is relatively elastic. What is that clear? Online student, are you able to get this? Hello, are you able to? Yeah, okay, fine, good. Okay, and copy the diagrams because you have to keep them in your memory. Okay, always. A relatively inelastic demand is like a vertical line. Flat demand curve is a elastic demand curve. And extremes like perfectly elastic is vertical, perfectly inelastic is, or perfectly inelastic is vertical, perfectly elastic is horizontal. Is that clear? Okay, fine. Just write one equation which gives us unit elastic demand. Unit elastic demand. Okay, is where P times Q is equal to C, a constant. P is the price of the product, Q is the quantity purchased. And that is always equal to a constant amount. Such demand curve will have a unit elastic demand curve. Okay, it's a very common kind of a demand curve, I'll tell you. Suppose if a family says that every month they will not spend more than, let us say, 1000 rupees on milk. Their budget is fixed. They will buy 1000 rupees on milk. So if price goes up, quantity will shrink. If price falls, they will buy more milk. But their total expenditure will always be equal to 1000. Such demand curve has the property that it will have unit elastic demand. Did you get this? Unit elastic demand, P into Q, and if you were to show it in terms of quantity, this will become 1000 upon P. Correct? We are just dividing P on both sides. So we get quantity demanded is equal to 1000 divided by P. That is our unit elastic demand curve. Okay, can I proceed? Just thanks Saida for telling me. Okay, now let us look at a closely related concept with elasticity. Okay, and it is also closely related with profit maximization. Okay, write down TR stands for total revenue for a firm during a period of time. During a period of time. Okay, usually we can think of it as per month, per annum, whatever. Okay, fine. Is it clear? Total revenue for a firm during a period of time. Okay, total revenue is money receipts, money received from sale of goods. That will give us what is called as the total revenue. Okay, now just with this help I want you, have you written this? Can I proceed? Okay, think of something like P and Q. Okay, there's an inverse relation between price and quantity demanded. So if, let us say, price is 0, quantity demanded is 10, price is 1. Okay, are you getting what I'm doing? I'm increasing the price by 1. As the price increases, quantity demanded will decrease by 1. Okay, so complete this table all the way till price becomes 10, and you should get quantity is equal to 0. Complete the diagram. Complete the schedule. This is called a demand schedule. Oh, very good. You've completed. That's amazing. 3, it is 7. 4, it will be 6. 5, it will be 4. Oh, sorry, 5, it will be 5. Barabar, na? 6, it will be 4. 7, it will be 3. 8 will be 2. 9, it will be 1. 10 will be 0. Did you all get this? Okay, so imagine this is the schedule for a firm that is to sell 10 units. They are at 0 price, 10 units will get sold at 1, 9, 8, 7. This is like what a firm can sell at various prices. Okay, now if I multiply price by quantity, P into Q, I will get what is called as the total revenue. Okay, so can you all quickly finish this table? Can you finish this table? And no calculator. You have to practice some numerical maths. You cannot use a calculator for this. Okay, quickly tell me the table. Got it, all of you? Okay. So with this schedule, this is giving us the total revenue. So one simple formula for calculating total revenue, remember, is total revenue in our simple parlance is price multiplied by quantity. Got it? What is the price and what is the quantity? Good, good. Thanks. Let us write a very, very important idea. And first let me define this. Additional, write down this very important idea, marginal revenue. Marginal revenue, and we can write this as MR. Okay, marginal revenue is change in revenue, change in revenue from selling one more unit. Okay, the change in revenue from selling one more unit is called marginal revenue. Okay, now just remember, we will have to do a little bit of a calculation here. Okay, but it would go in the reverse direction because our price. Okay, now just check here. I'm starting here. Okay, if you want to sell, your quantity was 1. Okay, from 1 to 2. Okay, 1 to 2. What would be the revenue? 16 minus 9. Okay, so that is 7. Okay, similarly, from this to this, from third unit, from second unit to third unit, your revenue is going up from 16 to 21. So what is the marginal revenue? 21 minus 16. Okay, that is 5. Compute all the other terms in this table. Label this as marginal revenue. Okay. The next entry, what will it be? From 3 to 4, revenue has gone up from 21 to 24. So it will be 3. Okay, 24 minus 21. What would be the next one? 1. Very good. Now is the tricky part. Revenue from 6th unit. From 25 it has gone down to 24. So 24 minus 25, if I do, I will get minus 1. Got it? Then if I, what will be the for the 7th unit? 21 minus 24, it will be minus 3. Okay, and then it will be minus 5, and this will be minus 7, right? This will be minus 7, and the last one, revenue is 0 and 9, it will be minus 9. Got it? Have you got the calculations, all of you? Online students, did you get the calculation? Okay, great. So what you see from this table is two things, okay? Remember one thing. Marginal revenue is, if you look at here, the initial quantity is 1, 2, 3, 4, 5. It is positive. Then it can become negative. Okay, so marginal revenue can be positive, negative, or zero. Okay, and if you draw the graph, I want you all to draw this graph. Okay, two graphs you want to draw. These are very important graphs: marginal revenue and quantity, and also total revenue and quantity. Marginal revenue and quantity, and total revenue and quantity. If you want, from this table, just copy down the two numbers. When marginal revenue is, this is 9, okay, just one thing, compute this quantity and marginal revenue. Okay, so you have 1, 2, 3, 4. For 1, quantity is equal to 1, the marginal revenue is here. This is quantity, and this is the marginal revenue 9. Okay, so copy it like that. 1, this is 9. For 2, it is 7. 2, it was 7. 3, it was 5, correct. 3, it is 5. 4, it is 3. 4, it is 3. Then 3, it is 4. Sorry, for 5, it is 3. 5 and 6. 1, it is 9. 2, it is 7. 3, it is 5. 4, it is 3. 5, it is 1, correct, yes. 5, it is 1. 6, it is, yeah, 6, it is, let me just write like this so that I am very clear about signs. 6, it is minus 1. 7 will be minus 3. Okay, 7 will be minus 3. 8 will be minus 5. 9 will be minus 7, and 10 will be minus 9. Did you all get this table? This is the marginal revenue curve for this particular demand function that we had. Okay, now on this graph, mark these points and draw the graph like so. Mark it 1, 2, 3, 4, 5, 6, all the way 7, 8, 9, and also remember minus 1, minus 2, minus 3, minus 4, like that you will get. Okay, so, and this is 1, 2, 3, 4, 5, like that you will get. Done? Did you get? done first one, it will be 9, then it will be 7, then it will be 5, then it will be 3, then it will be 2, sorry 3, then it will be 1, then it is minus 1, minus 3, minus 5, and minus 7. So if you join this graph, you will get a downward sloping demand curve like this, marginal revenue curve like this. Did you all get this? Yeah, you can plot. I'll give you time to do this, okay? All of you draw the graph. Oh, so good. That's absolutely right. That's absolutely correct, online student. So that is, and when you draw the graph, the graph is looking very messy, but you draw a nice and clean diagram. It will be something like this. Marginal revenue curve. You will get something like this. Okay. Marginal revenue and Q. So you will get like a downward sloping curve like this. Okay, this is our marginal revenue curve. Okay, I have deliberately showing two parts. It is cutting at some point and then it is becoming negative. A solid diagram. All of you got this? Did you all plot this graph? Done? Can I proceed? Okay. We want to understand a very important result, and now there is a very close relationship between marginal revenue and total revenue. Okay, remember this, marginal revenue and total revenue. Total revenue. Okay, let's write this. Let's recall marginal revenue. Okay, remember now marginal revenue means that entire function. Okay, marginal revenue is the change in, please write this again, change in total revenue from selling, change in total revenue from selling one more unit. Okay, marginal revenue is the change in total revenue from selling one more unit. Change in total revenue from selling one more unit. Okay, now this can be written, okay, marginal revenue, and I'm saying is a function of quantity. MR depends on quantity. So you can write this as delta TR upon delta Q. Okay, or let me write Q like this. Delta TR is change in total revenue, and delta Q is the change in quantity. Okay, and there is a calculus version of this which I'm not going to do right now, but remember this is same as dTR by dQ. It is the first derivative of total revenue with respect to quantity. Okay, so marginal revenue is the change in total revenue from selling one more unit. Okay, did you all get the notation? ये notation समझ रहे? dTR by dQ. Okay, it is a change in total revenue for change in quantity. Now write this very simple relation between marginal revenue and total revenue. It is when marginal revenue is positive. Okay, mathematically this statement is like this: marginal revenue is positive. When marginal revenue is positive, the total revenue will increase. The total revenue will increase. Got it? Now write the second thing. When marginal revenue is negative, the total revenue will decrease. The total revenue will decrease. Okay, it will go down. And therefore you get a very important result. See this third, let me write down, then we'll draw that graph. When marginal revenue, see it's positive and this is negative, so in between that what is the value? 0. When marginal revenue is equal to 0, then total revenue is at maximum. Total revenue is at maximum. Okay, so let me just draw a marginal revenue curve. Suppose if I have a marginal revenue curve as we did just now, quantity is like this. This is marginal revenue. It is positive here, negative here. Okay, if you have a marginal revenue curve like this, okay, mark this point as QM. Okay, now to the left of QM, if you see here, at each of this quantity, what is happening? Marginal revenue is positive. Okay, so till Q1 TR is marginal revenue is positive, therefore TR is increasing. So if I were to draw a TR curve, it would be like this. It would keep on increasing till I reach this point. TR curve would be increasing. Got it? And when it crosses this point QM that I have drawn, okay, what is happening? Marginal revenue is becoming negative. So total revenue will be decreasing. So just aside from QM, if I were to draw, as marginal revenue is falling or negative, total revenue is also decreasing. And at Q1, that is this QM, total revenue will attain a maximum value. Okay, so TR curve is like an inverted U. It is like this, and here where it attains a maximum value, MR is equal to 0. Okay, when marginal revenue is equal to 0, when marginal revenue is equal to 0, the total revenue is at its maximum. The total revenue will be at its maximum. Okay, so therefore TR curve becomes like this inverted U. Okay, the TR curve is a inverted U-shaped curve. Okay, just keep this in mind whenever we are trying to draw a total revenue. It will be like this. Okay, and whenever this is the point of maximum, at this point MR will become 0. To the left of Q dash, MR is to the left. Total revenue is increasing, therefore marginal revenue will be positive. And to the right, when total revenue is falling, MR will be negative. Correct? This case MR is negative, here MR is positive, and at this tangent point MR is equal to 0. Okay, have you all got this? This is the relationship between marginal revenue and total revenue. It is of very great importance in profit maximizing behavior of firms. Okay, so we'll come back to this model again and again. Okay, this is the marginal revenue and this is the total revenue. Okay, write one more concept. Write one more concept. It is called average revenue. Average revenue is total revenue divided by Q. Total revenue divided by Q. That will give you the average revenue. Okay, so suppose revenue is, let me give you a problem, revenue is rupees 500. Okay, and Q we are told is, or let me say P is equal to 25. Okay. Okay, let me put Q is equal to 25. Q is equal to 25. Can you all calculate and tell me what is the average revenue? What would be the average revenue? Total revenue is 500. Quantity sold is 25. What will be the average revenue? Yes, correct. Absolutely right. It will be 500 divided by 25. So 25 twos are 50, and this, so average revenue will be 500 divided by 25. That will be 20. Did you all get this? Have you all got this? Done? Can I proceed? Have you got? Okay. So we have defined three concepts now: total revenue, average revenue, and marginal revenue. Okay. In the normal demand curves that we see, AR curve is very similar to the demand curve, that is the price curve that we know of Troy. Okay. So this normal curve that we are seeing, actually P and Q, in a market structure, this curve will be called as the average revenue curve. And for this average revenue curve, firm will have a marginal revenue curve which is like this. Okay, the marginal revenue curve would be like this. Okay, this is the MR curve. Positive, 0, and then negative. Okay, and if you were to draw total revenue curve for this firm here, it would have been like this. Till this point, let me call this as Q dash. Okay, until Q dash, TR is going up. At Q dash, it hits the maximum and then it starts decreasing. That is how you will get the total revenue curve. Have you all got this? Okay, so one concept that we have to realize now, just right, elasticity and revenue. Okay, elasticity and revenue. Elasticity and revenue. Okay, now just remember one thing: demand is relatively elastic. Okay, demand is relatively elastic. Okay. Okay, now think of this. Okay, like something like this. This is like price and this is quantity. So suppose demand is relatively elastic. Okay, what it would mean, or you can even think of it like this: P into Q is equal to total revenue. Okay, if my price increases, okay, P by certain percentage. So I'm drawing a certain length of the arrow, and I want to show proportionately a much bigger arrow down. Why am I showing a bigger arrow? Because अगर ये 10% से प्राइस हमारी बढ़ रही है, तो क्वांटिटी डिमांड is going to fall by more than 10%. So symbolically, I just want you to think of this downward arrow is a bigger percentage change than change in price. Okay. For example, price could have gone up by 5%, and my quantity demanded could have gone down by 8%. Okay, that's why I'm showing a bigger line. Okay, but now what happens? Total revenue is a product of P into Q. Because price goes up by 1%, quantity demanded falls by more than 1%, my total revenue will decrease. Okay, so let us write this rule. Okay, write this rule. When demand is price elastic, when demand is price elastic, okay, increase in price will cause decrease in total revenue. ओके, तो अगर प्राइस बढ़ा दी फर्म ने एंड डिमांड एकदम इलास्टिक है, तो उनकी टोटल रेवेन्यू इज गोइंग टू डिक्रीज, सेल्स आर गोइंग टू फॉल, because customers will respond by reducing the demand for the good. Have you got this? Okay, now if think the reverse way, if price is cut by 5%, okay, price is cut by 5%, but my quantity demanded may increase by more than 5%, so it may go up by 8%. So in this case, what will happen? My total revenue will increase. So when demand is price elastic and price is cut, okay, what will happen? Total revenue will increase. Did you all get this? This is what happens when the demand is price elastic. Okay, this is what will happen when it is price elastic. Okay, let us just write the case for price inelastic, and then we will close the session for today. Okay, just one more concept we want to do. Okay, so if you know, when demand is price inelastic, when demand is price inelastic, okay, suppose price is increased by some percentage. Say, think like this, price goes up by 5%. Percentage increase in prices by 5%. Now my demand is inelastic, so quantity demanded falls but by less than 5%, so it may decline only by 2%. Something less than 5%. So if this is the arrow of a increase in price, my arrow for decrease in quantity is much smaller. Got it? I've kept the arrow length very small. So what will happen? Total revenue actually will increase. Okay. So when demand is inelastic, increase in price leads to increase in total revenue. Okay. The last result I want you to think on your own. What will happen if demand is, this is a price increase. Price increase. Imagine price is cut. If price is cut, that is ye cut kiya price. What would happen to quantity? Demand is inelastic, remember. So if you cut down the demand by 5%, okay, then quantity demanded may increase but by less than 5%. So maybe it increases only by, let us say, 1%. So I would say quantity by a smaller arrow, and I'm showing that it has increased only by 1%. So overall revenue, what will be the impact? प्राइस तो कट हो गई और क्वांटिटी भी ज्यादा इंक्रीज नहीं हुई है. So what will happen to total revenue? Decrease, correct. So total revenue decreases. So a price cut in an inelastic market leads to fall in revenue. Price cut in inelastic market. Inelastic market leads to fall in total revenue. Okay. Check if there is any problem for this in the textbook. Search, we can solve a problem and then we can stop. So this 1.3, we are doing 1.3. What page are the problem sets? '69. Okay, good. '69. Okay, we have done this problem number 14 now. 15. don't know what happened. I don't know why it is doing this with iPad. Yeah. You are able to see? No? In this stream it is coming properly. Okay. Just let me